the door to the refugees, and she was so heavily criticized. Do you recall that?
Right.
I was there with the refugees,
Oh la la.
traveled for 4,000 kilometers.
Oh la la.
Traveled for 1 month with them.
Poor people.
To set,
Poor,
all the way. Yeah.
poor people.
And I just feel depressed after that because this world can't be changed.
But now what happened in Gaza, in this place, is jail for 20 years, and now they are killing everyone. They cannot move out. It's too much. Yeah. much better to focus here. Yeah.
So, what makes you come into China? Is China the ideal place for you to translate your paper into, concrete, down to the earth products?
Yeah. Thank you so much for asking. Yeah, actually, there are many reasons behind my means coming to China, to Hangzhou. Of course, the economy in China is the best in the world, well known. When we are abroad in North America or in Europe, we see how China is moving up in terms of economy. But my motivation to come to China kind of the boom in science important for me, because I was also involved on all kinds of scientific committee and journal publication, and I was watching how now research in China is booming, So research is booming, science, and of course economy is booming, and of course I have of course the hope what I am doing as research one day can be translated to help people. Then of course, but first I came here to contribute more at scientific level, and the people I'm working with student and researcher, of course, can translate, also help our lab, our group to do those translation. So yeah, China is a good place these years for living and for economy and for science.
Yeah. Well, could you elaborate why China is the good place for this translation to be happening?
Yeah, because actually the main reason is experience, I can say, and speed. Means in China everything is very fast, and then they have all kind of program to invest on those translations in order to accelerate. So of course still have kind of selective is not really first arrive, first serve. No, means we have, but they have of course deep experience on those translation, because already proves they can do run the economy very quickly from research lab. So this is one of the motivation. Speed, because of course I am not really assistant professor, and then but again I'm working in a field, the brain-computer interface require more science than translation at this time. We start translating something, as you know, about maybe now brain-computer interface is a very hot topic in the planet, not only in China, but China, I think, have many more parameter or reason to take really lead on those translation.
And is the supply chain, the scale of the market, the level of industrialization helps China?
Yeah, I think all those parameters, of course, the population in China is half of the world, I can say, means very large, and also supply chain. China is more and more now independent on high tech. Of course, still have some connection with outside world for some, I think, high quality or high-end equipment. But I think the portion of those equipment is becoming less and less, more and more small in order, and China is now, you can find everything for those translation around. And of course now with this I think globalization, I can say the word, means do you do research here in Hangzhou or research in San Francisco is the same almost, because quality of lab are almost the same. We have access to any information also in internet everywhere, so no reason now to be in some different lab. Of course, when you have lab with more experience, is faster to translate. But I have, I think, also all the parameter to build a lab where I want, and this is why I came to, with the support I have here. I think I have now a lab in Hangzhou, kind of unique. I am mixing electronic with bio together, and we expect many actually outcome for industrialization.
How do you see the brain machinery industry in China? Is it promising? Is it like still haven't seen the silver lining? So what stage is it?
Yeah, okay, brain-computer interface, also we call brain-machine interface. So this is actually kind of strongly emerging now. Means there are many groups were doing something a long time ago. The majority were kind of wearable, means external, not really hesitating to touch brain like we do now since around 10 or more, 10 years or 15 years. So this is actually now is technology allowed and science allowed. For example, I don't know if you talk about vision or hearing, maybe 20 years ago, no way to understand how vision works. But now, of course, we have more knowledge and more equipment, top quality to know what's happening. Then if you understand, for example, what is vision, of course it becomes easy to make brain-machine interface to connect and to recover vision. If not, how to recover vision? The same for, you have more than 30 different diseases inside the brain. Alzheimer is a big issue, as you know, schizophrenia, dementia, we can enumerate, you know, so, and epilepsy, so stroke, many, you know, and all this, no solution yet. Brain-computer interface now is coming to contribute and to really to recover those functions. And this is behind my motivation to come to China and build something and try to be first on doing this.
Yeah, but some argues that brain machinery industry is still a future industry. It's not.
Right.
So what's your comment?
Yeah, I think anything related to body, you know, biomedical, not biotechnology, means the body inside take maybe 3 times or 4 times more than any other technology, because you need to validate on different steps, in vitro, ex vivo, in vivo. You have to test a long list of parameters to make sure can run for long term, because the issue is a long term. You can have something working for tomorrow, okay, nice, but what happened after 1 year or 2 years or 3 years? So some application, yes, still need to wait. It's not tomorrow, the market. But some other are ready already. For example, you know, Parkinson's, there are long-term stimulator for that. You talk about pacemaker, is 20 years old or more than 20, but now means pacemaker can stay in our body for 20 years and keep working. The same cochlear implant for those completely deaf person, they can recover up to 80%. Etc., etc. So now we are working on speech in our company here. Is also we have something working, but to go to clinic, I think also everyone knows about Elon Musk. This is we cannot really talk about brain-computer interface without mentioning Elon Musk. So now he has a lot of money, a lot of investor, and he's now starting clinical test. Means clinical means almost the end, back end of this technology. Still, we don't know what he's doing exactly, but some applications are almost ready. But if we want to talk about vision, for example, for blind, This is not ready at all. Maybe it takes 20 years, I don't know, or 10 years, or not for tomorrow. So it depends on the application. But helping for epilepsy, helping for maybe Alzheimer is too close. Of course, we cannot also skip without talking about AI. Artificial intelligence now is helping a lot to make those brain-computer interface. Brain-computer interface are what we call a closed loop neuromodulation. Means we can have, like the body, our body collects signal sensing, and our brain stimulate me to move my hand, to look, etc., etc. So we have a closed loop. Then we are imitating how the brain is working to solve the brain problem.
So what is your aim? What is your target to influence the world?
Yeah, actually, my target is really I am focusing on 4 main applications, you know. So, and my target, before I stop this adventure, is of course to find big solution for those, you know. And I am almost close by. Actually, also, my lab, we are doing biology. I am engineering background, but doing biology. We are trying to see the link between brain cell connection, because our brain have, you know, 80 billion cell. Connection between those cells when I am alive like this is through we call neurotransmitter, chemistry, ions. These neurotransmitters communications is the issue. If we can find a link between those neurotransmitters and the different diseases, will be great. So it means we can stimulate those neurotransmitters to solve, for example, schizophrenia, or to solve dementia, or etc., or even epilepsy. So this is my concern. I am trying to characterize those neurotransmitters, save one and abnormal one due to those different diseases. And we are in already.
So what does this company do in this map?
Okay, so now the company, again, we have large experience. I have large experience on doing neuro recording. Neuro recording you can do on different level from the brain. It can be external, we call EEG. You remove only the skin, and you can have another, and you remove the skull, you have third, etc., etc. So when you go from up to down, more you go down inside the brain, more the signal is more clear, bigger quality. Then you arrive to the surface of the brain. We talk about ECOG, electrocorticogram, what you mean is, or intracortical EEG. So this is at the surface. But now for different diseases, you have to go inside the brain, different layers also. For example, for vision, we are measuring parameter from occipital at the layer number 4 inside the brain. Now, answering your question, now we are using SEEG, means we have small holes. We can insert needle called electrode to the surface of the brain. But you know, our brain have map different region, like different city, you know. So we know which one is related to speech. This is well known. And then we go there with a collection of those needle kind SEEG. And with this, we can, from outside, do neuro recording. So this is actually to validate, we can do recording and speech encoding. And of course, we have used a latest algorithm on AI in order to quickly recognize what we want from this speech. So this is our experience with the brain in terms of recording, region, etc. is already done a long time ago. And now with AI, we have also all bio application. We are using different AI for this to predict, to see next, or to encode. And of course, we have now kind of system to validate. But the long term, we talk about, of course, doing something smaller, low power. People can live with this for good, you know.
Thank you.
Thank you.
We'll finish our interview.
Thank you so much. Yeah.
Yeah.